Good morning everyone. I am Chaitra PS and I am going to explain about join tables in SQL and outer joins. So let's start with the introduction. In any real world database, data is spread across multiple tables to make meaningful use of that data. We often need to combine it in useful ways. That's where SQL joins come in. They allow us to link rows from different tables based on a related column. Whether we are retrieving employee information with their department or customers order with payment details. Joins are the glue that holds relational data together. This presentation walks through the different types of joins in SQL, including inner, outer, equi-join, natural join, and multi-way join, and explain how and when to use them effectively. So let's move to join tables in SQL and outer joins. An SQL join clause combines records from two or more tables using common values. So these are the types of joins. There are four types of joins to be exact. The first one is inner join and outer join, equi join, and then natural join. Let's move to the inner join. An inner join in DBMS returns only those records that have matching values in both tables involved in the join. So if there is no match, the row is excluded from the results. So how is it means? If any two matches don't match, so the row itself is excluded. And this type of join is most commonly used join because it gives you only related data from both tables. It only gives the both matching data. So related meaning if they're related or if they're matching, it gives it. And the join condition is usually specified using the on keyword with a column that is common to both tables. So if there is any data that is common in both the tables, it uses on keyword. And for examples, joining an employees table with a departments table on a common debt ID will return only those employees who belong to a department that exists in the department table. Moving to the equijoin and natural join part. In a database management system, equijoin and natural join are types of join operations used to combine rows from two or more tables based on related columns. An equijoin specifically uses a condition with the equality operator to match rows from different tables. So if you want to match any two conditions, it uses the equal sign. So for example, if two tables have common column like debt ID, and equijoin would explicitly use a condition like table 1 dot debt ID is equals to table 2 dot debt ID to fetch the matching records. You have to use this syntax to obtain the matching records. And this type of join often results in duplicate columns if the join tables and columns with the same name. So if you have the same name, this will duplicate some columns or rows. So on the other hand, natural join automatically matches column between tables that have same names and compatible data types, and it eliminates duplicate columns from the result. Unlike equijoin, natural join doesn't do it. So it will terminate. It will terminate whatever duplicate columns is present because of the same names. So it will automatically avoid it. And the natural join does not require any explicit condition as it infers the join criteria from common column names. So it will join any common column, like if the same column have the same name, it will join it into make it by making it a single column. While equi-joins offer more control and flexibility, natural joins are simpler and cleaner but can lead to unexpected results if tables and columns have same name that are not meant to be matched. So I think it's better, equi-joins is better than natural join because equi-join is more flexible than natural join. Even when the problem in natural join is it might join the two columns even if they are not meant to join because of having the same common column names. Okay, so both joins are useful, but the choice between them depends on desired output and the structure of the database tables. Let's move to the outer join part. An outer join returns all matched records as well as the unmatched records from one or both of the tables. Unlike inner join which discards unmatched rows, outer join preserve them and fill in outer join, allows unmatched rows to appear in the result. Null values where data is missing. Outer joins are further divided into three types, and those are left outer join, right and full outer joins. So these type of outer joins helps in retaining important data even when corresponding matches don't exist in the other table. There are three subtypes in the outer join. The first one is left outer join, right outer join, and full outer join. So let me explain you this in briefly. Let's move to the left outer join. A left outer join returns all rows from the left table and matched rows from the right tables. So if no match is found in right table, null values are used for columns from the right table. So if any matches any data that doesn't match in the right table, so for example the values, it will return null. Mean it will put null in the right table. And this type of join is useful when you want to see all records from the left side, regardless whether there is a match in the right table. So, for example, if you join customers with orders, a left outer join returns all rows from the left table and the matched rows from the right table. So if no match is found in the right table, null values are used for columns from the right table. And this type of join is useful. It's useful when you want to see all records from the left side. So regardless of whether there is a match in the right table or not. Like for example, if you join this, so it will come. And this is the example for left outer line. Okay. Select tab from A to left join B on AID is equals to B dot ID. B is nothing but it's located in the right table. Let me explain you right outer join. The right outer join is nothing but the opposite of left outer join. So it returns all the rows from the right tables and it does whatever the left table left outer join does. But just the direction is different. So whether no match is found in the left table, null values are filled in. And this type of join is used when you want to ensure that all data from the right table is preserved, even if there is no corresponding match in the left table. And returns all rows from the right table and the matching rows from the left table. So if there's no match, the result is null on the left table. Like before it was on the right table, so in the right order it is in the left table. For example, select star A, so and right join B. So B is the left table here. Okay. No, B is the right table and A is the left table. Let me explain you full outer line. Full outer join returns all rows from both tables with matching rows from both sides where available. If there's no match, null values are used to fill in the gaps from either table. And this join is useful when you want a complete set of data from both tables, regardless whether they have matching rows or not. So it combines the effects of both left and right outer joins. Okay, this is the example. Select tab from A full outer join B on A is equals to, this program is nothing but combining both. Okay, this is multi-way join. A multi-way join or multi-table join involves joining more than two tables in a single SQL query. This is common in normalized databases where information is spread across several related tables. For example, joining order, customers, and products together helps you find out which customer bought which product with which order. So multi-way joins can use any combination of inter or outer or require accurate join conditions to ensure that the correct relationships among all tables are maintained. So multi-way join can automatically choose whatever join it wants. And this is the example. Okay. Select p number. This is the data variables, and this is the project join department. Okay, this is the table name, and you can join. So the location Stafford is wherever the Stafford is there, it will alter the data. And so here you can see this program code example. This is the example code. uh, you can use this. So for conclusion, SQL joins helps to relate data across multiple tables effectively. So understanding inner, outer, equi-join, natural join, and multi-way joins is crucial for database design, and it's useful. Thank you.